Hello friends, welcome to ACE Tutorials. Today we are going to discuss Transient Response Specification or Time Domain Specification of Step Response of Second Order Control Systems for zeta value between 0 and 1. This is the step response of second order control system for zeta value between 0 and 1. In this you can see a transient response and steady state response. In its transient response, you can observe the oscillations are decreasing with time, which is nothing but underdamped oscillation, that is for zeta value in between 0 and 1. You can see in this for zeta is equal to 0, we are getting undamped oscillations, and for zeta between 0 and 1, we are getting underdamped oscillation. You can see with respect to time oscillations are decreasing, and then finally we'll get a stable output, whereas for zeta is equal to 1 we are getting critically damped oscillation, and zeta greater than 1 we are getting overdamped oscillation. These are the different response for different zeta values. And in this we have considered zeta value in between 0 and 1. So you can see the oscillations are decreasing with time, and then it reaches to steady state. After passing certain time period, which is known as transient period, it reaches to steady state. In this, steady state output remains within plus or minus 2% error band, that is tolerance band plus or minus 2%. This tolerance band can be 0% or it can be plus or minus 5%. It depends on the system. Here we have taken tolerance band of plus or minus 2%. In this transient response, we can measure certain parameters like delay time, rise time, peak time, settling time, peak overshoot, peak undershoot. With these parameters we get to know how fast the system performs. Let us see one by one. Delay time. It is the time required for the response to reach 50% of the final value is called delay time. You can see here, which is represented by TD, and it is given by the formula TD is equal to 1 plus 0.7 zeta divided by omega n, where zeta is damping ratio and n is the natural frequency of the oscillations. Next, rise time. It is the time required for the response to rise from 0% to 100% of the final value. It is denoted by TR, and it is given by the formula TR is equal to pi minus theta divided by omega d, where theta is equal to tan inverse into root of 1 minus zeta square divided by zeta, and omega d damping frequency is equivalent to omega n into root of 1 minus zeta square. One thing you have to make a note, in this rise time we have measured from 0% to 100%, that is for zeta value in between 0 and 1. If zeta value is equivalent to 1, that is for critically damped, we are going to measure rise time from 5% to 95%, whereas for zeta greater than 1, that is overdamped oscillation, for that we will measure rise time from 10% to 90%. You need to remember for underdamped we will consider rise time 0% to 100%, whereas for critical damp we will consider rise time measurement from 5% to 95%, and for overdamp we will consider rise time measurement from 10% to 90%. These are the different methods we are going to use for different zeta values. Next, peak time. Peak time, it is the time required for the response to rise from 0 to first maxima, and it is denoted by Tp. You can see the formula. Tp is equivalent to n pi by omega d. Here n represents n is equal to 1 for first overshoot, n is equal to 2 for first undershoot, n is equal to 3 for second overshoot, n is equal to 4 for second undershoot. That means here the peak time can be measured at first maxima, means then we need to consider n is equal to 1, which is also be known as the time measurement at first peak overshoot, or else if you want to measure the peak undershoot, first peak undershoot, then we'll consider n is equal to 2. Depending upon our requirement on the analysis, either we can consider the first maxima or second maxima or third maxima, whichever you are representing. At that time you should remember that the n value keeps on changing based upon the requirement. For first maxima n is equal to 1, for first minima n is equal to 2, for second maxima n is equal to 3, for second minima n is equal to 4. Like this n value keeps on changing depending upon the requirement. So next is settling time. This is defined as the time required for the response to decrease and stay within specified percentage of final value. That means you can see that after passing through certain period, the output settles. So the time taken to output settle is called settling time and is denoted by Ts. In this you can see that Ts is equal to 4 times of time constant I have taken, where time constant is equal to 1 divided by zeta into omega n. This 4 times of time constant is taken for tolerance band of plus or minus 2%. If it is 0%, for 0% tolerance band, we'll take time constant, for 0% tolerance band, we'll take settling time 5 times of time constant, whereas for plus or minus 2%, we'll take settling time of 4 times of time constant. If it is plus or minus 5%, then the settling time will take 3 times of time constant. In this we have taken the example of tolerance band of plus or minus 2%. Then you can see the formula. Settling time I have considered 4 times of time constant, and time constant is equivalent to 1 divided by zeta omega n. By substituting this t value in this, I will get settling time Ts is equivalent to 4 divided by zeta into omega n. Remember, if in the question, if anywhere if it is asked settling time for 0% tolerance band, means it will be 5 times of time constant. If it is for 5% of tolerance band, then the settling time will be 3 times of time constant. Next you can see the peak overshoot. So it is the largest error between the reference input and the output, and it is denoted by MP, and the formula is given by MP is equal to e power minus pi into zeta divided by root of 1 minus zeta square into 100. These are the time domain specification of second order system, or else we can say transient response specification. You need to remember these formulas. We will be using these formulas further to solve some problems. Hope you understood this video. For more such videos, like and subscribe my channel. Thank you.